Hello students and welcome everyone to next chapter preparation of the organic chemistry, that is alcohols, phenols, ethers. Here again I have come with a previous year questions. You know that previous year question solving is very important. It gives you a good idea about the paper, what questions could be asked. It is just like, this doesn't mean that you have to just study the previous year question. You have to solve the question in and around of those questions. So I am going to discuss all these questions which were asked since last 5 to 6 years. I have taken the unique questions, the questions which were repeated, I haven't taken those questions. So list of the question may be little less, but it covers the maximum of the question. So keep watching, keep learning. Here first question is asked. The correct order of boiling point of the alcohol having same number of the carbon atoms. Means basically they are talking about what? This question is talking about the isomer. Same number of the carbon atom. Means you know that boiling point is dependent on the intermolecular forces. If I write, I'll just write this is for your understanding. Boiling point is directly proportional to intermolecular forces. Okay. Now intermolecular forces if I talk about the van der Waals force, or in general what we can say is directly proportional to the molar mass. Molar mass is more than intermolecular force is also more. But this is not the only condition. We have to understand intermolecular force is also dependent on what kind of intermolecular forces are operating. Intermolecular force is also dependent on type of intermolecular force operating between the molecules. If this is high, then boiling point will be high. Yes, means I'll discuss about those intermolecular forces which operates between the molecule. The strongest one is the hydrogen bond force. Understand, hydrogen bond force. Then dipole force. Dipole force, and there is van der Waals force. This is Waals. The strength of this is very less. Hydrogen bond force, right? So these are the things on which the intermolecular forces depend. But what they have said that the alcohol is what? Having a same number of the carbon. Then you have to decide based on the branching. Like here I will write that was a general explanation about the boiling point. Here I will say that same number of the carbon. Let's say I am taking this same number of the, let's say this is the alcohol. I'll take one alcohol. This is CH3, this is CH2. Like this alcohol is a primary alcohol. Yes, this is an alcohol which is primary alcohol. How do I understand that this is primary alcohol? Because OH is connected to the carbon, it is directly connected to only one carbon. This is how we understand it. This is primary alcohol. So I design one more alcohol containing same number of the carbons. I'll write 1, 2, 3. and maybe how many 5 are there, no? I'll put this and the OH. This is CH3, this is hydrogen, right? This is secondary alcohol, but it has same number of the carbons and the molecular formula will be also same, right? This is secondary alcohol. This is secondary alcohol because OH is connected to this carbon and it is directly connected to 2 carbon. Okay. One more possibility we write tertiary alcohol. We'll write tertiary alcohol, OH. Here OH is connected to this carbon and it is directly connected to what? 3 carbon, 1, 2 and 3. This is tertiary alcohol. This is tertiary alcohol, right? So if you see over here, in this case, the branching, okay, here we will decide, molar mass will be same because molecular formula is same. C5, H is how much? 7, 10, sorry, 8 and 12. 12 hydrogens are there, right? And 1 oxygen. Over here also if you see, there are C5, how many hydrogens? 6, 7, 8, 9, 10, 11, 12 hydrogens and 1 oxygen. Here also you count, it is same C5, H12, O, right? Same number of the atoms are there, means what, the molar mass will be same. So I cannot say that define based on the molar mass. So we'll have to depend on this parameter, like in haloalkanes also I discussed about that. See, boiling point is inversely proportional to branching. Inversely proportional to branching for isomers. This is with respect to what? Isomers, because the molar mass are same. More is the branching, less is the boiling point. So tertiary has maximum branching, little less for secondary, and the primary has least, right? So over here, least boiling point will be for tertiary, secondary and primary will be maximum. So this is your answer. Next question, write the structural formula of 2-ethoxy-2-methylpropane. Whenever this type of questions are asked based on IUPAC, you have to always like from where to start. Many times students don't understand from where to start. Shall I put 2-ethoxy first, 2-methyl first? Understand, you have to put the carbon chain first, a parent chain first. Then you put rest of the things. So how do we decide? Propane. It is written propane. Propane means what? Prop means 3. You have to form the parent chain of the 3 carbon. On second position, like this is my carbon 1, this is carbon 2 and this is carbon 3. Okay, on second position there is ethoxy. How does ethoxy look? Oxygen and CH2, CH3. This is ethyl and this is oxy. And this is what? 2. On same carbon there is methyl. On same carbon there is methyl. So this will be the structure of the compound. This was very simple. Identify the structure of the final product X and Y form in each of the following reaction. Understand, very good question. This is very nice question. This what they have written is this is alkene and a hydroboration oxidation. I just write HBO. Hydroboration oxidation. You shouldn't be writing that for the exam, HBO. You should write full. Okay, I will also write the full word. Hydroboration oxidation. Hydroboration oxidation. Okay. You should know the reagents like B2H6, OH minus, H2O2. These are the reagents of the hydroboration oxidations. Every time examiner will not write the reagents. You should know the reagents of that. Now, what is this reaction? What is this reaction? In your NCRT, I'll discuss, you have a hydration of the alkene. I'll discuss both the reaction. Anything can be asked. No? So I'll discuss first hydration. Hydration. Like this reaction is hydration of alkene. Let's have the clarity. This reaction, why we are learning? It is a preparation of the alcohol. It is for the preparation of alcohol. How we can prepare? One of the method for the preparation of the alcohol. So there are two methods. One is hydroboration oxidation. One is hydroboration oxidation. And other is acid catalyzed hydration. Acid catalyzed hydration. Okay, these are the two methods which we are learning. Now, what is the meaning of hydration? Students will know this. What is hydration? It is a addition. It is addition of water to alkene. Now, what is the meaning of addition of water to alkene? Water has two parts. One is H plus and the other is OH minus. Like we used to do HBr, H addition of the HBr. H plus was the positive, Br minus was the negative. Same way we are doing the addition of the water, right? So this is the thing. Now there is a difference. If you are doing the hydroboration oxidation and the acid catalyzed hydration, difference between them is that this gives you this reaction gives primary alcohol. Product is primary alcohol, or we can say that you get the anti-Markovnikov product. Okay, let's not talk about the anti-Markovnikov. You get a primary alcohol. That is what you have to understand. And over here, the product can be secondary or tertiary alcohol also. Okay, so if you want to prepare exclusively a primary alcohol, you should use a hydroboration oxidation. And if you want to prepare a secondary or the tertiary alcohol from the alkene, you may use a acid catalyzed hydration. Just a second. Huh? So here hydroboration oxidation, whenever we say, so what are the reagents? Reagents are like this: B2H6 or BH3, or in the presence of OH minus H2O2. These are the reagents. What are the reagents of acid catalyzed hydration? H plus and the water. Okay, so these are the two things which when we add water molecule to the alkene, we get the product, but depends what you are doing, acid catalyzed hydration or a hydroboration oxidation. So here it is mentioned directly in this question, hydroboration oxidation. Okay, so this is your water molecule. You consider the water molecule H2O. Okay, I'll write two parts of it. I'll write two parts of this, that is H plus and the OH minus I am writing. So according to this, the OH will go over here, anti-Markovnikov's product you get. I'll write anti-Markovnikov's product. Actually anti-Markovnikov's is only for the HBr, but just for you to make the relationship between that reaction and this. This is anti-Markovnikov's product. Anti-Markovnikov's product. Don't write this for exam. I'm just explaining like don't write this in exam anti Marconi's product and all. This is just for your understanding. So OH will be getting attached over here and H will be getting attached over here. That's it. Means your product, final product is CH2, OH. If it was acid catalyzed hydration, the OH would have come over here. Means we'll do this. Okay, not the second reaction. I'm just showing you. If it was acid catalyzed hydration, a second reaction, and if this was the thing, and you are doing acid catalyzed hydration H plus and water, then addition of water would have taken place this way. Understand the difference. OH would have come over here. So this is the difference between two reactions. So we have discussed with the help of this two reactions. Okay. Now what about this reaction? So here CH3, CH2, OH. This is propanol. Right? So whenever you add acid, understand a simple formula. Okay? Note, or everyone should know this. Addition of an acid to alcohol, addition of acid to alcohol leads to dehydration of alcohol, leads to dehydration of alcohol. You know that whenever you do the hydration of the alkene changes to alcohol. See, understand, you do alkene, understand this process. Alkene is there, you do hydration of this, add water molecule. It gets converted to alcohol. But if you do the dehydration, of this will get converted to what? Alkene, right? So this is the thing. You are adding a H2SO4. Now don't wait every time they will give you H2SO4 only. Sometimes they may just write H plus or just write acid. Okay. So over here what will happen? Dehydration. I'll write it this way. In this case, there is only one possibility. That is, you can remove this water molecule. So you will get what? Only one type of alkene, that is propene. I'll just discuss one more reaction around this. If the question was like this, if there was an alcohol like this, butane 2-ol was there, you add acid to this, H plus, or it would be shown this way also, H2SO4. Okay. Now there are two possibilities. One H is this, and the other H which will be removing, HOH will be, other set which will be removing is this. A or B, right? So I'll write, if it is removing A set, then you get this alkene, and if you are removing a B set, you will get this alkene. So this is but 2 in, and this is but 1 in. This is minor because you know alkene which is having less number of the alkyl group on the either side of the double bond is less stable. This is major. Fine. Okay, so we'll go ahead. Write a chemical equation for each of the following. For again 2 marks. One reaction for 1 marks. A phenol is treated with bromine water. First one. This reaction is directly given in NCERT. Okay. If this is your phenol, you treat this with bromine water, Br2 water. Means very high concentration of the bromine. That is what we can see. What you get is this phenol, one Br will come, like ortho para, but all the ortho and para, this is also electrophilic substitution reaction. This comes under the category of the electrophilic substitution reaction, where you get 2,4,6 tri bromo phenol. Very straight reactions. Vapors of the ethyl alcohol is passed over heated copper. Second reaction is dehydrogenation. Understand? Not dehydration, dehydrogenation means removal of the hydrogen. Two hydrogens, a kind of oxidation reaction. Ethyl alcohol. Ethyl alcohol is this CH3 CH2OH. Okay, means I'll show purposely it this way. Two hydrogens, which we are removing over here. You heat the copper at 573 Kelvin, and what will happen? You remove one hydrogen from here and one hydrogen from here. So the product what you get is CH3 C double bond OH. This is ethanol. Very simple. Again and again I have to check whether it's working. Sometimes what happens is that memory is full and camera stops recording. Okay, this roadmap question. See, I'll suggest one thing. Once you are very much perfect with the name reactions, all the other reactions, like by looking at the reaction you understand what examiner wants to ask, or you can solve simple examples, then you should try a roadmap. Simply directly don't go for roadmap question. First do the questions which are very easy and doable, where you can remember the reactions and apply the tricks or remember the mechanisms and get the answer. Then you go for this roadmap. Roadmap actually not very tough, but first only if you go to do this, then what will happen that your confidence may go down with respect to organic chemistry. You need to develop some confidence and then go for a roadmap question. This question is very simple. It was asked for 2 marks. Okay, so here they have said compound X reacts with a magnesium in the presence of dry ether. If you don't know what compound it is, let's solve this. Reacts with a magnesium. It reacts with a magnesium in the presence of the dry ether to form Grignard reagent. Now, how this Grignard reagent will be formed? R Mg. Okay, what I'll do is, instead of writing a X letter over here, I'll write compound Z, because I want that X for halide. There is a compound Z, okay, which reacts with magnesium to give you RMgX. Then this is the representation of the Grignard reagent. This is how we represent the Grignard reagent, RMgX. This is what the Grignard reagent is. How we must be getting this? How we should get? To get this Z should be what? Z should be my alkyl halide. Some alkyl halide. This Z should be my alkyl halide. There only I will get RMgX. This is what we know from the reaction of the alkyl halide with magnesium. It gives you a Grignard reagent, right? So my Z, I'll just make a point over here that Z is what? Rx. I don't know what alkyl halide it is. I'll just write this as Z, or I'll write this in a red color. This will be good. Z, and this is Rx, alkyl halide. Compound. This is compound Z reacts to the magnesium in the presence of dry to form a Grignard reagent. So this is the Grignard reagent, which is then treated with Y containing 3 carbon to form the adduct, which on hydrolysis gives 2-methyl butane 2-ol. Okay, don't worry, they have said something called as an adduct in that. Okay, but we have to understand that this Grignard reagent which is there, RMgX, reacts with someone which contains 3 carbons, let's not reveal, or I don't know what it is, but after reacting this with this, you get certain adduct in between, okay, and this adduct, I'll just write adduct, this on further hydrolysis, gives what? Gives 2-methyl-butane 2-ol, 2-methyl-butane 2-ol, 1, second position, 2-methyl-butane, butane 2-ol. So this is the product which you are getting over here, 2-methyl-butane 2-ol, name of this product. Now this reaction is somewhere, we are understanding that this reaction is somewhere, we are using reactions of the preparation of the primary, secondary and the tertiary alcohol using a Grignard reagent. This is like, if this is Grignard reagent, then this should be certainly a carbonyl compound, some carbonyl compound. Carbonyl means what? Aldehyde or a ketone, certain aldehyde or ketone. Okay, then you will get that in between intermediate, and you do the hydrolysis of this adduct, you get this. Okay, so this is a whole diagram. Now we'll understand the Grignard reagent reaction first. We'll understand a Grignard reagent reaction. So this is your carbonyl, means it can be aldehyde or a ketone, means if this is R and this is H, then this is aldehyde, and if both are R, then it is ketone. So whatever it is, aldehyde or the ketone, the reaction sequence or the mechanism will be same. I'll write it this way, I'll not mention what it is. Okay. This is reacted with the Grignard reagent RMgX. This is very easy to understand. Okay. You see that these two groups which are connected, I'll keep that intact throughout the reaction. Mechanism is there, but sometimes tricks help more. Okay, this is I'm keeping intact over here. Okay, and this you see over here, this is partially negative, this is partially positive, partially negative. This will attack over here. Means over here, this R will come and this O minus. This forms OMgX. And further, when you do the hydrolysis of this, what you get is alcohol. This alcohol you will get over here. In this case, you will get this alcohol after doing the hydrolysis. This is what the Grignard reagent reaction is. This reaction sequence is very simple. Like if it was, I'll take aldehyde. If it was aldehyde, I'll just illustrate this. If it is a normal aldehyde, you will get after reaction with the Grignard reagent, I'll write little small over here. If this is your aldehyde, after reaction with the Grignard reagent RMgX, what you get? Of course, dry ether is there. Don't forget this. This R and H I am keeping as it is. This changes to OMgX and this changes to R. I'll put this dash to understand that this dash is from what? Grignard reagent. And further, when you do the hydrolysis, you get R, H, R dash and OH. What you are getting? A secondary alcohol. Okay. If it is a ketone, I'll show over here. If it is a ketone, means ketone, how I'll represent? And you do the Grignard reagent, RMgX in the presence of dry ether. What you get? These two groups, I'm again keeping intact. I'm not touching them. This changes to OMgX and this R double dash from the Grignard reagent. Further, you do the hydrolysis what you get is R, C, R dash, R double dash, OH. This is tertiary alcohol. So what we can understand, very important, that aldehyde gives secondary alcohol on reaction with Grignard reagent, and ketone gives tertiary alcohol. Okay, and only formaldehyde is also a case of aldehyde. Formaldehyde gives primary alcohol. You cannot prepare, you can prepare all, but formaldehyde gives primary alcohol. So this is the whole summary. So if we go back over here for this reaction, what alcohol is this? This is tertiary alcohol which you are getting. Okay, so what should be my adduct over here? We'll go back from here. My adduct should be this CH3, CH2, CH3. I'll write this OH this way, or I'll write OH over here. As a student, there are a lot of confusions, so I'll write over here this way. OH and CH3. Okay, one and same. So this is CH3 and this is OMgX. X is halide. You consider this as a Cl also, no issue. OMgCl. Then I said that you have the carbonyl, right? So, but the carbonyl, they have said is a 3-carbon system. So, 3-carbon system, carbonyl can be only ketone, CH3, CH3. I'll just reorganize this. I'll write CH2, CH3 and CH3. So now over here, you see, or again I'll do it this way. I can write a carbon ketone with 3, same this way. And what should be my R over here? My R should be ethyl magnesium chloride. Okay, if this is ethyl magnesium chloride and this is my final product, this should be my ethyl magnesium chloride. And what should be this? Ethyl chloride. Clear? So Z is ethyl chloride and what was asked? Y. Y is acetone. Y containing 3 carbon. So this is my Y. So this is acetone or propanol. Okay, organic reactions are that simple. Okay. Write IUPAC name of the given compound. Okay, very simple. This is carbon 1, this is carbon 2, this is carbon 3. There are no prefix, there are no substituent on this, there are no substituents on this. So name will directly start with the word root, that is prop. Why numbering from this side? So that functional group get the lowest number. That's why 1. Prop 2 in, this is primary, this is word root, primary suffix, and last E replaced with a functional group like E and E. Last E replaced with the functional group suffix, that is what position? First position. 1 all. This is the name of this compound. Prop 2 in 1 all. Out of phenol, second question. This question was for 2 marks. This contains 1 mark. Okay. Out of phenol and ethanol, which one is more acidic? Okay, so I'll write this name over here. Out of phenol and ethanol, which one is more acidic? The question is this way. Okay. So I'll give you the explanation. I'll tell you which is more acidic. This is phenol. This is phenol. And ethanol is this. CH3, CH2, OH. This is ethanol. Now what is the meaning of acid? These two compounds will act as an acid when it can give away its hydrogen very easily. If it is giving away its hydrogen, then that compound is good acid, H plus. It should give its. So when this breaks when it gives away its hydrogen, O minus and the H plus is formed. Over here, CH3, when it acts as an acid, O minus and the H plus is formed. Okay, when phenol acts as an acid, this is how the dissociation takes place. When ethyl alcohol acts as an acid, this is how the dissociation takes place. Now we have to decide the stability of the negative charge. Over here negative charge is on oxygen, here also negative charge is on the oxygen. Now where the negative charge is more stable, understand any negative charge or any intermediate note, you have to always fix this in your mind. Any intermediate mediate which is stabilized by resonance are always more stable, maximum stability. Usually what happens is that intermediates are not stable, but among intermediates, the one which is stabilized by resonance is more stable. How do we understand? You see this pi, sigma and negative. This is a conjugation. But over here it is sigma, pi, there is no pi only. There is no conjugation. In fact, this negative charge is destabilized by this plus I effect. Over here it is stabilized by what? Resonance, right? This negative phenoxide ion, this is called as a phenoxide ion. So which is more acidic? And this is ethoxide ion. Ions it is. Okay, in which case the splitting will take place more where stability of the negative charge is more. So phenol is more acidic than ethanol. So answer is, you should be writing it this way. Phenol is more acidic. Phenol, how you should write for the exam? Phenol, you have to write the statement, is more acidic than ethanol. Reason is not asked. Okay, so it's okay, you just write the thing. If reason is asked, you may write the reason. If the reason was asked, why? Reason. Due to stabilization of the phenoxide ion, you can write stabilization of phenoxide ion due to resonance. This is the reason if it was asked. Okay, write the preparation of tertiary butyl methyl ether. Tertiary butyl methyl ether by Williamson synthesis. So we should know what is tertiary butyl methyl ether, right? Tertiary butyl is this CH3. This is what? Tertiary butane. This is tertiary butane, right? You remove one hydrogen, it is tertiary butyl. So tertiary butyl ether is what? This is CH3. Okay, you are asked to write the reaction for the tertiary butyl methyl ether. So to prepare this, the reaction we know as a Williamson synthesis. Williamson's synthesis. That is, it is written this way. If you want to prepare this, you should be taking alkyl halide plus R, a sodium alkoxide, and you get R dash OR, or you can write ROR dash plus NEX. This is alkyl halide. This is sodium, general I am writing, sodium alkoxide, and this is ether. This is salt, sodium halide. Okay. Now the challenge, many students find it difficult. The challenge, you want this ether, right? But the condition for this reaction is that this should be primary. This alkyl halide which you are choosing, it should be what? It should be primary alkyl halide. Primary alkyl halide, and this should be what? Tertiary. This should be tertiary. Okay. If it is opposite, this is tertiary and that is primary, the elimination reaction will take place and you will get alkene in that case. This is the condition which is clearly mentioned in the NCERT textbook. So over here you are taking a tertiary, this is the primary one, means this part of the alkyl halide you will be taking this as a CH3I, and sodium alkoxide you are taking it this way, CH3O Na. After reaction, what you get is this. Right, this is what is the reaction. It was asked. So methyl iodide, this is methyl iodide or iodomethane. Right, iodomethane. Iodomethane. Now, some people may think, students may feel that, okay, if I do opposite, if I take this, what you will get? Means if I take this, okay, why you shouldn't be taking this? You take this as iodide, you take this as this CH3 ONA. What happens is that this acts as a strong base. Strong base leads to the elimination. The elimination reaction takes place. Means over here, dehydrohalogenation takes place. You will get the alkene for this. This reaction is also discussed. It is written nicely. This compound you will get. So you have to take care of this. Right? So all this was for 1 mark. This was for 1 mark, and this was for 1 mark. Right? Total 3 marks was. Okay, phenoxide ion is more acidic than an ethyl alcohol because phenoxide ion is more resonance stabilized than phenol. Phenoxide ion is more resonance stabilized than alcohol. There is more hydrogen bonding in phenoxide. Phenoxide ion is more resonance stabilized in phenol than ethoxide ion. I will write ethoxide ion. Ethoxide. Then this is correct. Just now we had discussed. For the following reaction, the product P is asked. Obviously, the answer is this. what will happen? This is a salt, O minus CH3I. This is partially positive. This will attack over here, electron reach, no? The old bond will break. And what you get is this, OCH3. This is methoxybenzene, methoxybenzene. This is also known as anisole. This is anisole. So your answer is option C. This was the paper in, I guess, 2022. The questions were MCQ. When acetone is treated with appropriate Grignard reagent, the product obtained is 2-methyl-propane-2-ol. The Grignard reagent they have asked. Means you are treating this acetone. Acetone is what? Propanone. You are treating this acetone with Grignard reagent. Okay, Grignard reagent to obtain. We don't know what is that Grignard reagent. They have asked what is that Grignard reagent, RMGX. And this, after getting that adduct and hydrolysis further, if you do the hydrolysis of that product, what you will get? You will get this CH3, OH and R. Now what is the thing they have said? You are getting 2-methyl-propane-2-ol. What is this? This is, if I write over here, this is, if I consider, this is 1, 2, 3. 2-methyl-propane-2-ol. This is the thing. Means what should be my Grignard reagent? To get this R over here, this should be CH3. This should be CH3. Methyl magnesium bromide. Methyl magnesium iodide. Okay. This is iodide. They have mentioned iodide. So methyl magnesium iodide should be your compound. Right? Then only you will get 2-methyl-propane-2-ol. In the following reaction, the product Z is. This is very simple. Again, electrophilic aromatic substitution. This is nitration, but this is concentrated. Since this is concentrated, you get the compound like this. All the positions, ortho and para, are substituted with what? Nitro. Concentrated. Dilute, then you will either get ortho and para. To get, right? So this is 2,4,6 trinitrophenol. This is also known as a picric acid. Picric acid. Okay. Write the chemical equations to show what happens when phenol reacts with a bromine water. I guess this was done previously. I will not do this again by mistake. I have taken it up. Okay. Not wrong. I have done this. Ethanol reacts with concentrated sulfuric acid. I'll do this. Ethanol, very simple. CH3, CH2, OH. Okay. You add acid to the alcohol. They have written H2SO4, sulfuric acid. What happens is the alkene. You get the ethene over here. Dehydration. This is dehydration reaction. Dehydration of alcohol. Right? Methanol is treated with the ethyl magnesium bromide. Methanol. Methanol means what? I told you, it is a formaldehyde. Methanol is this. Hydrogen, carbon, and the hydrogen. This is methanol, also known as a formaldehyde. Methanol means what? Formaldehyde. Treated with ethyl magnesium bromide. CH3, CH2 MgBr, followed by what? Hydrolysis. So final product, what you get over here, this two group will remain intact. You will get this OMgBr, and over here this R group will come, CH2 CH3. Further hydrolysis of this will give you OH, CH2 CH3. So if I write it in nice format, like this is my carbon 1, carbon 2, carbon 3, while writing a name, this is CH2OH. First carbon has two hydrogens. This is CH2 second, and this is CH3. Name of this compound will be what? Propane 1-ol. That's it. Propane 1-ol. Okay. Write chemical equation for the following conversion. A, phenol is there. Phenol is there. You need to convert this to benzene. Understand, if this is reacted with a zinc dust, a powder of zinc. Zinc is not a stable element. Zinc gets oxidized. Understand? Zinc gets oxidized to Zn2 plus always. Means zinc gets converted to what? Zinc oxide in this case. That's why this is in +2 oxidation state. Zinc is not a stable element. If it was stable, then if it is not reacting with oxygen, moisture, then we would have said that would have been one of the precious metal like gold, silver, platinum. Since zinc reacts and it changes the oxidation state to +2, right? So here zinc is in what? 0 oxidation state. When it reacts with this oxygen, you get the other product as zinc oxide. And this hydrogen is anyway there, no? Which you don't show. So this is what the reaction for that benzene. Zinc oxide. Acetaldehyde to butanol. Acetaldehyde. Sometimes these names, students get confused with these names. Acetaldehyde. Like we know acetic acid. What is this acetaldehyde? Right? Acetaldehyde. Question. Acetaldehyde to butanol. Butan. You need to convert this butan to all. How to remember acetaldehyde? See, everyone knows acetic acid. CH3, CO, OH. This is acetic acid. Acetaldehyde will be aldehyde. Means you will be putting acetaldehyde as this CH3, C double bond OH. If you know acetic acid, acetaldehyde is very easy to remember. Acetaldehyde to what? You need to convert this to what? CH3, CH2, OH. You cannot do it by reduction, because if you do the things by reduction, then what will happen? The point to be understood over here is that if you do the reduction, the product will also have the same number of the carbon atom. Like reduction of the aldehyde will give you a primary alcohol, but it will have same number of the carbon. But if you see acetaldehyde has 2 carbon and the product what they have asked is 4 carbon, means you want extra more 2 carbons. From where we will get this? This is possible only with the Grignard reagent, right? So what I do is I want this product, that is I want final product is butanol. I want this CH3, CH2, CH, OH. I want this product. Okay, butan 2-ol. Acetaldehyde. So what Grignard reagent you are going to use? I'll just align this. I will align this compound this way. I'll write this OH CH3. Means extra this is butan 2-ol. This is secondary alcohol, right? Butan 2-ol. So what will happen over here? You will take CH3, CH2, Mg, Br also you can take, right? What is the compound you are going to get is CH3, carbon H. This is OMg, Br. And this you are connecting over here, CH2, CH3. This further hydrolysis, if you do this hydrolysis of this, what you will get? You are going to get the compound this way. Right? So this is what? Secondary alcohol expected product. This is carbon 1, carbon 2, carbon 3 and a carbon 4. So this is what the reaction is, and it is butan 2-ol. Butan 2-ol. Anisole to 4-nitroanisole. I'll write this C over here. Anisole to 4-nitroanisole. What is anisole? Methoxybenzene. This is anisole. You have to remember some of the things. You have to always remember some of the reaction. What is anisole? Their IUPAC name, common name. This is methoxybenzene. If you react 4-nitroanisole, means this is my carbon 1, carbon 2, carbon 3, carbon 4. You need to do nitration. If you do the nitration, how do we do? Concentrated HNO3 in the presence of concentrated H2SO4. The compound what you are going to get is this OCH3 and nitro plus, you have to write only major. They have asked major. Don't write this one, last one. Don't write this, it is there. If it is, since they have asked major product, only one product. Okay, this is 4-nitroanisole, also known as para-nitroanisole. Arrange the following alcohols in the decreasing order of their boiling point. Pentan 2-ol, methyl 2-butyl, all these are isomer. All these are isomer. Means pentan 2-ol will be this. Sorry, pentan 1-ol. This is pentan 1-ol. 1, 2, 3, 4, 5. This is pentan 1-ol. Two methyl butan 2-ol means 4 carbons on a parent chain. In second position there is methyl. In second position there is OH. CH3, CH2, CH3. Right? So this is 2 methyl butan 2-ol. And last is 3-methyl butan 2-ol. 3-methyl butan 2-ol. 1, 2. OH will get a lowest number. So this is OH. This is 3 now. Okay, this is H. This is 1, this is 2, this is 3, this is 4. 3-methyl butane 12. If you see the decreasing order, the highest boiling point will be this pentan 1 all. So answer is this pentan 1 all. Pentan 1 all. Then here there is more branching. On same carbon there are many atoms. So next is 2-methyl butane 2 all, and then list is 3-methyl butane 2 all. So this will be the order for this answer. An organic compound A with a molecular formula C7H8O reacts with the HI and forms compound B. Compound B on zinc dust gets converted to simplest aromatic hydrocarbon. Write the equation for the above equation. Very simple. C7H8 means we have to understand C7H8 with it will be very close to something which is benzene. Like if I consider this, they're talking about this OCH3 C7H8, 1 oxygen, 7 carbon, 8 hydrogens over here, right? Like how 8 hydrogens? Here there is a hydrogen, here there is hydrogen, hydrogen, hydrogen and a hydrogen. Here there is no hydrogen because already it is making a 4 bond. 5, 6, 7, 8. This is a carbon, 1, 2, 3, 4, 5, 6 and 7, right? So it is fitting into this formula. This reacts with the HI, this reacts with the HI. We know that what compound we get? We get a phenol. Phenol and CH3I. See, understand, I'll explain you this mechanism, very important. Whenever phenol reacts with the HI, methoxy, not phenol, anisole, I mean, this is anisole reacts with the HI, anisole or a methoxybenzene, anisole or methoxybenzene. When it reacts with the HI, how it goes? Mechanism is very simple. See, you always understand that whenever there is HI is a very good source of what? It is an acid H+. It is a very good source of H+. So there is a lone pair of electrons over here. It will attack over here to form a new bond. So this is O, CH3, H, and the positive charge is formed on the oxygen because oxygen has donated its electron to form a new bond over here. So this is what the intermediate you get. To give stability to this bond, either this bond can break or this bond can break. I'll call this as A and this as B. Now if it is going via A, if A bond is breaking, then you will get this, a positive charge over here. Okay. Plus you will get O minus and CH3. Okay, if it is going via A. If it is going via B, the compound what you are going to get is this O minus plus CH3 plus. Now among this cation, carbocation which is formed is most unstable because it is forming on the pi bond, most unstable. This is stable. Like it is said that primary is least stable carbocation, but in this case when you compare this, compared to this, this is at least somewhat stable. Now further it will react with the H part, sorry, where I was, yeah. So what will form is this, okay, and then it will react with the H again, and this will be getting converted to OH, and other is CH3I, right? That's why. Now this is what they are saying. So this is the compound A, this is my compound A, and compound B did not tell, they said that B just reacts with a zinc dust. So phenol is the one who reacts with a zinc dust, phenol is the one, this is B, B reacts with zinc dust to give you what? Benzene and zinc oxide, and this is the simplest aromatic hydrocarbon. This is simplest aromatic hydrocarbon, that is benzene, right? So this is the reaction, roadmap reaction. Acetic acid can be converted to ethyl alcohol by using what? Understand the flow chart. I have discussed this in one of the video where I have discussed about 1 trick 10 reaction. You can just watch that video where I had told you about if it is a primary alcohol, if you do the oxidation of this, detailed explanation is there in that video, you can watch that video. It will get converted to aldehyde, and if you do the oxidation of this further, it gets converted to carboxylic acid. This gets converted to carboxylic acid. So acetic acid can be converted to ethyl alcohol. Sorry, acetic acid, yes. Means if you want alcohol from the carboxylic acid, then you should do reduction. Reduction of what? Reduction of the carboxylic acid to aldehyde, and aldehyde to what? Reduction of the aldehyde. Right? Very simple. Primary alcohol, how do we represent primary alcohol? I am representing it this way, RCH2OH. This is changing to aldehyde, RCHO. Why this is called as oxidation from here to here? There is a removal of the hydrogen. Like there are 2 hydrogen less over here. Why this is from here to here it is called as oxidation? Because there is 1 extra oxygen in this compound, addition of the oxygen, that's why oxygen. Reverse is reduction. Okay. You want to convert what? Acetic acid. Acetic acid is this, CH3COOH to what? You don't want to stop at aldehyde to directly ethyl alcohol. Ethyl alcohol is this, CH3CH2OH. So you should be using what? For this process, a strong reducing agent, And if you remember that lithium aluminium hydride is a strong reducing agent, Reaction won't stop at aldehyde. Understand this. PCC is an oxidizing agent. This is oxidizing agent. It won't work. Oxidizing agent. Okay. This is also oxidizing agent. CrO3. Jones reagent, that is what we say, oxidizing agent. Understood? So these are the things. So answer over here is option A. Okay, over here last question, that is phenol is treated with a zinc dust. This we have done. Okay, 2-ethoxy 2-methyl propane is treated with HI. We'll do this. 2-ethoxy 2-methyl propane 1 2. Second position there is ethoxy 2-methyl propane. 2-ethoxy 2-methyl propane is treated with HI. What will be the product? We'll understand the mechanism of this. Mechanism is very simple. HI. Okay. HI ka H plus, good acid, strong acid. It will attack over here. Understand? It is forming a bond over here. It is forming what? Bond, new bond. Right? CH3, CO, CH2, CH3, H and the positive charge. Which bond will break? There are two possibilities. To give stability to this positive charge on oxygen. Understand, positive charge on oxygen or the electronegative element is most unstable. There is nothing as unstable as having a positive charge on the electronegative element and negative charge on electropositive element. Like when it comes to intermediate, positive charge cannot be present on the electronegative elements, right? So over here, I'll say this as A and this as B. So if it is going via A, then you will get what? You will get this as a carbocation. One bond will break. And here the carbocation will form. And the other product, what you are going to get is this. CH3, CH2, OH. If you see over here, I will explain you about. Okay, here I just make a correction. Here this is OH because this OH will be formed over here. Okay. Again, I made a mistake here. Sorry. This will be OH, not this. That I minus will connect over here. Just make a correction over here. Where I was, yes. Here this is OH if it is this. And if it is going via B, then the compound what you are going to get is CH3, OH, CH3, CH3 plus, I'll write this other part. So this is primary carbocation which is formed over here, and this is tertiary carbocation. Right? So this is more stable, and then your I minus will come and attack over here to give you what? To give you CH3, CH3, CH3I. Is that clear? So the product will be this is 2-iodo 2-methyl propane, one word, it should be one word, propane. This is ethanol.